we're going to look at the volume of pyramids and cones. So, just like how prisms and cylinders were similar formulas, prisms and cones are similar, pyramids and cones are similar like prisms and cylinders were. So as a reminder, for the volume of a prism, we are doing the area of the base times the height, right? What we just discovered is that for pyramids and cones, the volume is going to be that, but divided by 3. So the area of the base times the height divided by 3. And when we are looking for pyramids, we should be looking for something that has the base of the shape. So like here is a hexagon, and it comes to a point. So the side opposite that base is a point. So let's look at these shapes here. First thing I need to be identifying is what is the shape of my base. So I'm going to highlight that here. And then identifying the perpendicular height of that prism, matching you up to the point on the opposite side. So that tells me that this 12, that slant height, is extra information. So first what I'm going to do is I'm going to calculate the area of my base. So I have a base of 8 times 8, which gives me a base area of 64. So for our volume, I'm going to take that base of 64, multiply it by our height of the prism, which is 9, and divide it by 3. So I want to see that being plugged in, then you can do that in the calculator. So 64 times 9 divided by 3 is 192 centimeters cubed. Number 2, looking at our base, this time I see a triangular base opposite the point at the top, right? And then the measure that's connecting that point to that base, that perpendicular measure, is right here. So I'm going to find the area of my base first, remembering that it's a triangle, so I need to divide by 2. So my sides that connect at the 90-degree angle are 8 and 12 divided by 2. So 8 times 12 is 96. Divide that by 2, and you get a base area of 48. So for our volume, we are going to take that base area of 48 times the perpendicular height of the prism, which is 16, divided by 3 because it is a pyramid. I plug that into my calculator. 48 times 16 is 768. Divided by 3 gives me 256. Since there were no units, I'm just going to say units cubed. So that was a square pyramid or a rectangular pyramid. This is a triangular pyramid. Now, as soon as I see the circle with the pointed shape, I know that it is a cone. So I see my circular base on the opposite side of this point, and I see that they connect right here. So for my area of my base, not forgetting that for circles, our formula is pi r squared. We are given the radius here of 3. So my formula for my base is going to be pi, so 3.14, times our radius of 3 squared. So I'm going to plug in 3 times 3 is 9, times 3.14 gives me 28.26. So that's our area of our base. For our volume formula, we're going to take that base area of 28.26 times our perpendicular height, which should be given to you and is not given here. So we're going to say that this is 5.2. Okay? So, actually we're going to say this is 6.3. Sorry about that. Okay. So we're going to multiply it by that height of 6.3. Divide that by 3 for our final volume. So we've got 28.26 times 6.3 divided by 3 is 59.346, which I'm going to round to about 59.3 meters cubed. So just as a quick reminder, the reason that that couldn't be used, that was our slant height, not our perpendicular height. And that is it.